Hi, welcome to another video of Calculus 1. In this video, I'm going to explain how the problems are solved using the derivatives of hyperbolic functions as well as derivatives of inverse hyperbolic functions. First, take a look at what these derivatives of hyperbolic functions and hyperbolic functions. So we have d over dx sinh x is equal to cos x d over dx cos x equal to sinh x d over dx hyperbolic tan x equal to secant hyperbolic secant x squared, and d over dx hyperbolic cosecant x equal to negative hyperbolic cosecant x times hyperbolic cotangent x, and d over dx hyperbolic secant x is equal to negative hyperbolic secant x times hyperbolic tang x d over dx hyperbolic cotangent x is equal to uh, negative hyperbolic cosecant x squared. So these are the six derivatives that we're going to use in this case, along with the other rules that we're going to along with the other rules that we learned earlier. So the first example that we're going to look at is uh, d over dx hyperbolic cosine 3x squared plus 1. So the function that we know is this. So what we can do is we can take this as u and then apply the chain rule. So let's see what are we going to apply chain rule here. So you can put d over du hyperbolic cosine u times du over dx, and this is hyperbolic cosine u is equal to hyperbolic sine or sinh u times d over dx. U is equal to 3x squared plus 1. So from that we can get sinh u is sinh 3x squared plus 1, and then the derivative of this can be taken as using the sum rule plus 1, and then putting everything together you can get sinh x 3x squared plus 1 equal to, this is 3 times 2x plus 0, so you can write 6x times sinh 3x squared plus 1. So that's the answer for that. And the second example, so this is example 1, and our second example, example 2, is to find d over dx sinh x times tang x. So this is a product rule. So you put as in product rule sinh x times d over dx tanh x plus tanh x times d over dx sinh x. So this is sinh x times d over dx tanh x is equal to hyperbolic secant x squared plus tanh x times hyperbolic cosine x. So this is cos x. So um, you can take this as sinh x 1 over or 1 secant hyperbolic x. We'll keep it here and then move 1 over cos x there and then plus tanh x times cos x. Um, and then what we can do is we can take it as this is tanh x, so tanh x times secant hyperbolic x plus cos x. You can put it in that way, or you can put it in other ways as well, putting, but you can leave it like that. So that's our second example. And going back to some more examples, we can look at some more examples. If you do this example, example 3, y equals hyperbolic cosine squared 9 minus 3t. We need to find dy over dt. So I take dy over dt, and this is d over dt cos squared 9 minus 3t. So what I can do is first you can take the power formula. I think you might remember that we did d over dx g of x to the power n is equal to n times g of x to the power n minus 1 times g prime x, or you can apply the chain rule. So I'm going to use this formula here. It's going to be 2 times cos 2 minus 1 9 minus 3t times d over dt cos 9 minus 3t. And with that, you get 2 times cos 9 minus 3t. And then I can put this as u, and then taking the chain rule, d over du cos u times d over dt 9 minus 3t, because u is 9 minus 3t. So from here we get 2 times cos 9 minus 3t. This is going to be sinh u, and then if I use the sum rule, d over dt 9 minus d over dt 3t, and from this what I get is 2 cos 9 minus 3t. Sinh u is 9 minus 3t, sinh 9 minus 3t, and from this we get 0 minus 3. So finally we get negative 6 cos 9 minus 3t times sinh 9 minus 3t. So if I use any other trigonometric identities, I may be able to simplify this further. But if you get to that far, that'd be pretty good. And if I do another example, you are given y is equal hyperbolic cotangent t divided by 1 plus hyperbolic tangent t. We need to find dy over dt. So you find d over dt, y is equal to d over dt, hyperbolic cotangent t divided by 1 plus hyperbolic tangent t. So if you use the quotient rule, I can put 1 plus tang t squared. You first put 1 plus tang t, then find the derivative of the numerator. Then you put hyperbolic cotangent t times d over dt 1 plus tang t. So this is 1 plus tang t times d over dt hyperbolic cotangent t is equal to negative hyperbolic cosecant squared t minus hyperbolic cotangent t times d over dt 1 is 0 plus d over dt times t is equal to hyperbolic secant squared t and divided by 1 plus tang t squared. Now from this onward it's algebra, so you can use minus cosecant hyperbolic cosecant squared t minus cosecant squared t times tang t minus cotangent hyperbolic cotangent t times secant squared hyperbolic secant squared t divided by 1 plus tang t squared. So you can simplify this further. This is negative cosecant squared, hyperbolic cosecant squared t, minus this is 1 over sinh t. So I want cancel to one sinh t here. So this is 1 over sinh t squared times sinh t over cos t minus cos t over sinh t times 1 over cos squared t divided by 1 plus tan t squared. So this cancel to one of these, and then you can cancel this to one of these. And by taking the common denominator, sinh t times cos t, what you can do is negative sinh t times cos cube t minus 1 and divided by sinh t times cos t times 1 plus tan t squared. So this is negative 2 plus sinh t times cos cube t divided by sinh t times cos t 1 plus tan t squared. So that's our answer for that problem. Okay, that's how you solve problems using the derivatives of hyperbolic functions. And let's look at how to solve problems using inverse hyperbolic functions. So the derivatives of inverse hyperbolic functions are explained in a previous video, but I will remind you what those are. U over dx sinh inverse x equals 1 over square root of x squared plus 1, and d over dx cos inverse x equals 1 over square root of x squared minus 1, d over dx tan inverse x is equal to 1 over 1 minus x squared, d over dx hyperbolic cotangent x inverse is equal to inverse cotangent x equal to 1 minus 1 minus x squared, and then d over dx hyperbolic secant inverse x equal to negative 1 minus negative 1 over x times square root of 1 minus x squared, and then you have d over dx hyperbolic cosecant inverse x equal to negative 1 over x to square root of x squared plus 1. So these are the 6 derivatives that we can use to solve the problems. Uh, so, and also we can use these identities in case cos squared uh, x minus cos sinh squared x equal 1. And then you can divide everything by cos squared x, and you get 1 minus tan squared x equal sech squared x. And yeah, so these identities can also be used here. And let's see what things we can do. We can use this kind of function. Let's put this one. Y equals, this is an example. Y equals sinh inverse square root of x squared plus 1. Find dy over dx. So when you find dy over dx, d over dx sinh inverse square root of x plus 1, you can write by using this derivative. If you take this as u, you can write the chain rule d over du sinh inverse u times du over dx. So from that you get from that you get 1 over square root of u squared plus 1 u squared plus 1 times d over dx x squared plus 1 to the power half. Well, again, you can use a chain rule. You can put this function as v if it is complicated to put u, and then you can write the chain rule again. This stays here, 1 over square root of u squared plus 1, and then you can write the chain rule d over dv v to the power half times d over dx d over dx v is x squared plus 1, right? And then this is 1 over u is square root of x plus 1. U is square root of x plus 1. So instead of a square root of x plus 1, use u squared. So that means square root of x plus 1 squared plus 1. And then this is half times v to the power negative half times d over dx x squared plus d over dx 1. From this we get 1 over square root of x squared plus 1 plus 1, and this is half 1 over square root of v times 2x plus 0. So this 2 cancel with that 1, and within the square root sign we get x squared plus 2, and then the square root of v is x squared plus 1 square root, right? So that's v is square root of x squared plus 1, and then you have this x times x. So the final answer is x, and you can bring this square root sign, everything inside, x squared plus 2 times x squared plus 1, right? So that's our final answer. This is how you use the derivatives of inverse trigonometric functions as well as the chain rule to solve problems. Let's take a look at another one. Y equals e to the power cos inverse x. Now we can again apply chain rule by taking this let u equals cos inverse x, right? So what you're trying to find is dy over dx, right? And if I take like that, dy over dx is equal to d over du e to the power u, because I define u as cos inverse x, times d over dx cos inverse x. Now, from our previous knowledge, this is e to the power u times d over dx cos inverse x is equal to 1 over square root of x squared minus 1. So this is 1 over square root of x squared minus 1. So e to the power u is cos inverse x, cos inverse x times what? Over square root of x squared minus 1. This is dy over dx. So that's our answer. So we have many problems like that that we can solve uh, by using the derivatives of inverse uh, trigonometric functions as well as the derivatives of not inverse hyperbolic functions as well as the derivatives of hyperbolic functions. Um, there are several problems like that, and we can use the same thing to solve those problems. Okay, so with that, I would like to conclude this video and hope to